Yeah, today we are going to discuss regression analysis using our data set attend DTA to examine whether attending lectures has a causal effect on final exams performance. Our dependent variable is the standardized final exams score, and our explanatory variable of interest is the number of lectures attended. Other control variables are current term GPA, cumulative GPA prior to the term, which is the prior GPA, and coverage entry test score, which is ACT. Now first we start with a simple regression by looking at the relationship between the number of lectures attended and the standardized final exams score. Using the regression that we have done, we can see that the coefficient on attendance using the simple regression is 0.027. By implication, attending one additional class on average is associated with an exam score of 2.7% of a standard deviation higher. If we estimate a simple regression like this, then we may be omitting certain variables that are likely to affect number of lectures attended and also the final exam score. Example of such variable may be the test language and parental income. Now if you look at our control variable, you can see that they are all measures of student exams performance, and they are likely to associate with ability. Now we can look at multiple regression using the two controls. Now we have current term GPA, which give an idea of all final exam score in current times. Now we know that number of lectures attended can influence the current term GPA causally, which makes the current term GPA a bad control. And you can see that the coefficient on attendance switches the sign to negative 0.035. By implication, students who manage the same current term GPA, if they don't attend, are probably better students. So there is a serious selection bias, which is negative. So inclusion of current term GPA does not necessarily affect the unbiasedness of the ordinary least squared estimator, but it can have some negative effect on the variance of the OLS estimator. Now we also have predetermined variables like cumulative GPA prior to the term and coverage entry tests. Both variables measure students' ability, and they are very important controls. For instance, prior GPA will give an idea of diligence of the individuals. So including prior GPA with attendance, the coefficient on attendance became 0 and insignificant, and this is something that we expect because there may be some confounding problems with prior GPA here. So omission of prior GPA and ACT in the analysis will lead to some inconsistencies and bias in estimating the effect of interest. This will lead to a reduction in the variance of the estimator. Now, what we are interested in this estimation, or the causal relationship between attendance and performance, it will be very difficult for us to use the ordinary least squared estimator to achieve causality. So the first question we should ask ourselves is, have enough other factors been held fixed to make a case for causality? If we have experiments, then it's easy to establish causality. For instance, we know the control and we know the treated groups. Now looking at our data, attend DTA, it's not easy to do any experimentation here. So what is needed actually is a technique that can help us to achieve some exogenous variation in attendance. And we can use the two-stage least squared instrumental variable estimation by instrumenting attendance with carriage proximity, because we know that carriage proximity actually correlates with attendance, and it can affect performance through attendance. Using OLS to estimate the causal effects of attendance and performance, requires that there must be no unobservable inferences on performance that are also correlated with attendance. And this moment condition must be achieved. And it's difficult to achieve this moment condition because we are using observational data. For instance, this assumption may be violated if other variables can affect the final exam score, like parental income and the test language. Now, the two-stage least square instrumental variable can therefore help us to address the issue of endogeneity. This is done by estimating two systems of equation, the first stage and the second stage. The first stage looks at the effect of our instrument proximity on attendance. And the first stage helps us to isolate that part of attendance that is uncorrelated with the error term. And that part is used to estimate the structural equation of the effect of attendance on the standardized final exam score. The parameter of interest is beta 1, which measures the marginal impact of a unit increase in attendance on the standardized final exams score. The other control variables are captured in vector X here. Now, for the two-stage least square instrumental variable to come out with consistent estimates, certain conditions must be satisfied. The first condition is the condition of relevance. We expect that the proximity instrument must have a strong correlation with attendance. And exclusion restriction, we expect that the proximity instruments may not or must not actually correlate with our independent variable, which is a standardized exam score. And it can only affect our dependent variable, which is a standardized score, through its effect on attendance. And monotonicity, we expect our instrument to be equally assigned. Thank you.